We'll solve some problem based on thermochemistry. So these are the problems of thermochemistry. So I have taken the topic of enthalpy of reaction. So let us see how to solve this type of questions. So again, calculate the enthalpy change when 6.8 grams of ammonia is passed over heated cupric oxides. The standard heat enthalpies ammonia gas and cupric oxides and waters are -46, -155 and -285 kilojoule per mole respectively, and the change is ammonia plus 3/2 Ca cupric oxide plus is give you nitrogen, water and this copper. So this is the basically reactions given here. So we have to use this data and to find this what is the enthalpy change, that is the delta H of this reaction, heat of the reactions. So again we can see here what we can see. So delta heat of the element form. So element form we have nitrogen. So we can see here. So nitrogen is, that is 0. So for this heat of the element for nitrogen is 0, and if you take the solid form, so delta heat of the this one copper is delta heat of formation standard enthalpy of the copper is also 0. Why? Because they are solid form and this is also pure gas. So for pure gas, for pure solid, we are not taking their heat of the external heat of the enthalpy. So to which again now we can use this formula. So what is the formula? The delta heat for change is equal to the summation of delta H of product minus summation of delta H of reactant. So product is what? So product we have here water. Okay, so water minus ammonia plus cupric oxide. So we can write here 3/2 into heat of standard of water minus heat of standard of ammonia minus heat of 3/2 heat of standard of cupric oxide. Okay, so this is given here. So if you subtract it, this value, so right here 3/2 heat of enthalpy external heat. So external heat enthalpy of water is into -285. Okay, here -46 on here will be -3/2 and cupric oxide is -155. So on solving we'll get here -149 kilojoule. So we got per mole changes how much, this we got that. Now we can see this changing only happens with the ammonia. So ammonia when react with the cupric oxide will get this much. Okay, so we have been asked how much if 6.8 gram ammonia is passed, then how much enthalpy is the change. So if 17 gram ammonia brings enthalpy change, so that is 149 kilojoule. So if you take here 6.8 grams of ammonia, so how much it will bring? So it's very easy. So 149 divided by 70 into 6.8. So we'll get answer here 59.6 kilo. So this is our basically answer. Heat of reaction for this C10H8 with react with oxygen, and it will give you 10 molecules of water and 4 molecules of water. Constant volume is -12.28.2. 2 kilocalorie at 25 degrees centigrade. Calculate the heat of reaction at constant pressure at 25 degrees centigrade. So again we have given this reaction. So in this reaction we can see that enthalpy is given here. Sorry, internal energy they have given here. We are asking what is the enthalpy. So we write the formula. We know that delta H is equal to delta U plus delta N into R into T. So here we know that delta U is delta U is how much? -1228.2 into 10 to the power 3 calorie. Okay, and delta N is given also here 10 minus 12, that is -2. Temperature is given here 298 Kelvin and R is given 2. So that you can put this value over here -1228.2 into 10 to the power 3 and plus we can put here value -2 into 2 into 2, 98. So on solving, so it is nothing, now it becomes very easy. So we'll get here 1,229,392 calorie, or we can write in shortcut 1.23 into 10 to power 3 kilo calorie. So this is our answer. So at 25 degrees centigrade temperature and constant pressure, complete combustion of 1 mole of ethylene yields carbon dioxide plus water with the evaluation of 336.2 kilocalorie heat. Compute the value of heat of reaction for the same amount reactions at 27 degrees centigrade and at constant volume. So again, the reactions is given here. What is reactions? Reaction is nothing but the C2H4 when it reacts with the oxygen. Okay, so it will give you here 2 molecules of carbon dioxide plus 2 molecules of water, and delta is again given here minus 336.2 kilocalorie. It is given here. So now you can use the formula delta H is equal to delta U plus delta N, the gaseous molecules, and RT. So here gaseous molecule is given here 2 minus, so we can say 2 here, 2 is there here, the 2 minus 1 plus 3 equal to minus 2. So it is given here. So now this is in liquid form, so liquid we cannot take it. So 2 minus, this is gas, this is gas, so this is gas, we have to take gas. This is the delta N is the gaseous molecule. So 2 minus 1 plus 3, that is equal to minus 2. So we can put directly our value here. So this is given here 336.2, and internal energy we don't know, we asked here minus 2, and R is given here, so delta N, so R given here 2 into 2 kilocalorie, so it is 2 into 10 to the minus 2, and temperature is 300. So if you solve it, delta U will be your 335.0 kilocalorie. So this is our answer. We will see. First we have to consider the following reactions. OF2 plus water will give you oxygen plus HF, and if heat of formation for OF2 is OF2 hydrogen and HF are 20, minus 250 and minus 270 kilojoule per mole at 298 Kelvin, then calculate the standard internal energy change for the reaction. So you can use it, and so heat of the reaction is nothing but the summation of heat of the product minus summation of heat of the reactions. Okay, and we know that standard heat of enthalpy of this hydrogen is 0. Okay, because it is in element form, it is in element form, it is 0. Okay, so we can use the remaining value. So delta heat of standard of OF2 will be not OF2, so we will take the overall value. This is nothing but here minus 20 kilojoule per mole, and similarly heat of reaction for water they have given here plus 250 kilojoule per mole. Okay, HF is also given, so delta energy of HF is given here minus 270 kilojoule per mole. So we can write here delta heat of reaction overall, so that is 2 into heat of standard of HF, okay, and plus heat of standard of oxygen, that is 0. We know that heat of standard of OF2 plus heat of standard heat of enthalpy is 0. So here you put value, this will be your 2 into minus 270, this will be your 0, okay, minus this will be your plus 20 plus minus 250. So on solving we will get here 310 kilojoule. So this is the heat of the reactions. Now they are asking a standard in energy change. So standard is delta U in standard form. So we know that this is 310 they have given here. So we know this formula, delta heat of standard equal to delta U into energy standard plus delta N R into T. So now we know that delta heat of standard is given this much. So we can directly put value minus 310 into 10 to the power 3, and delta U standard, and R is given here. So most of N is, so N we can see that, so N will be your, so this is your HF is gas, water is gas, or OF2 is gas. Okay, so this will be your 0. Okay, so what will happen, so we will take here 2 minus 1, So 2 minus 2 minus will be 1 equal to 2 plus 1, 3 minus 2. So 3 minus 2 will be your 1. So delta Ng will be your 2 plus 1, 3 minus 2 is equal to 1. So here you put value 1, R is 8.314 and here temperature is 298 Kelvin. So on solving we will get here minus 300,247.5, or we can write here minus 312.47 kilojoule. So this is our answer. So here you keep it in mind. So we can take enthalpy of oxygen is 0, but we can count in the gases molecule. So 3 minus 2 is equal to 1. Formation of carbon dioxide from graphite to 15 degrees centigrade at 15 degrees centigrade, and constant volume is 97,400 calorie, and that of carbon monoxide under the same condition is 25,400 calorie. So what heat should be evolved when 100 liter of carbon monoxide measured at Enthalpy is burned in the excess of oxygens? So both reactant product being at 50 degrees centigrade. So here we have to use the data, that is carbon plus oxide, because we have to find carbon dioxide, the heat of formation of carbon dioxide, and after getting the heat of formation of carbon dioxide, so we have to go for the number of moles of carbon dioxide, because we have to find out with how many 1 mole of carbon monoxide is giving how much heat, and if it is given 100 liter means how much moles of this one CO is there. So carbon monoxide will give you here, carbon monoxide enthalpy is how much, it is minus 25,400 calorie, and for carbon dioxide is how much is there, this will directly it will give you CO2, that is delta E will be minus 97,400 calorie. Okay, so it is calorie is given. Okay, so we have to find out. So this is equation number 1, this is equation number 2. So subtract 2 minus 1. So if you subtract it, so you will get here C plus C, this will cancel O2, so this will come minus. So here answer will be your CO plus half O2, it will give you CO2. So answer here delta E will be minus 72,000 calorie. Okay, now we need to find out the moles of this gas, how much moles of carbon monoxide is present. So moles of carbon monoxide, you can use the ideal gas equation, we can use the ideal gas equation. So on ideal gas equation we will get the moles of carbon monoxide. So PV equal to RT. So PV is how much, so PV is your 1 into 100 liters of carbon monoxide divided by 0.0821 and multiplied by here 273. So answer you will get here 4.46 moles of carbon dioxide at Enthalpy. Now one more thing, if you take 1 mole of carbon monoxide, it is giving how much heat. So this is the giving here heat 72,000 calorie. Okay, this is the moles of heat. Now for 4.46, if you take 4.46 moles of carbon monoxide, so how much it will give heat? So definitely it will be here 72,000 multiplied by 4.46. So here you will get answer 3212 calorie. So again delta U will be how much? So again this is your internal energy, this is nothing but it will give you internal energy, and delta H is equal to delta U plus delta N RT. Okay, so delta H we need to find out. So delta U is given here, you can put this value over here. So this is your minus. Okay, if you multiply this is minus, delta U is minus. So again this is given out. Okay, this heat is given out. So here you write here minus 321120 and plus what is the moles of delta N. So delta N will be here, we can see here 1 minus is given here 1 minus, so it will be your 1 plus 3 by 2. Okay, so it will be your 1 plus, so 1.5 and multiplied by 2 into 298. So on solving we will get here 321408 calorie. So this is our answer. So this much heat will be evolved. That is when carbon monoxide react with the oxygen to give carbon dioxide. The molar heat of formation of ammonium nitrate is minus 367.54 kilojoule, and those of N2O plus H2O are 81.46 and minus 285.8 kilojoule respectively at 25 degrees centigrade and 1 atmospheric pressure. Delta, then calculate the delta H and enthalpy and internal energy of the reaction. The ammonium nitrate react will give you N2O plus water. So already it is given here. So again you can use a delta heat of reaction is equal to summation of delta heat of product minus summation of heat of the reactants. So this is given here. So this is nothing, we know that this is the nitric oxide, so we can take, this is a liquid form, so this will be 0. So we can directly use this value because this will also 0, solid is also 0. Okay, so we have two value, one is liquid, one is your, so liquid they have given value here, liquid they have given value, and gas they have given value. So we can take this two value, okay, and this will be an ammonium nitrate. So molar heat of formation of ammonium nitrate they have also given here. Okay, so we can take each and every value properly. So right here delta heat of reaction will be, so here summation of we can put value 81.46 plus 2 into this will be your minus 285.8 and here minus 367.54 kilojoule. Okay, so 81.86, so this is your nitrous oxide. Okay, and this is 285, this is for water, and this is for 367. So this value is given for NH4 3. Okay, so this is heat of the product, so this is heat of product, heat of the reactant. Okay, heat of the product. So on solving we will get here minus 122.6 kilojoule. Now we have to find out the internal energy. So delta H is equal to delta U plus delta N into RT. Okay, so here delta H is given here minus 122.6 into 10 power 3. This value is given here, this is kilojoules. So put this here. Delta U we have to find out, and delta N is nothing. So we can see here, this is gas 1 N2O, so only one gas is there, so put here 1 because N2 is the only one gas, so this is 1. And then R is how much? So R will be your 8.314 and temperature is 298 Kelvin. So we can find out delta U will be minus 125077 joule. Okay, or we can write here 125 minus 0.077 kilojoule. So this is the internal energy of the reactions. Change of enthalpy of methane, enthalpy change for carbon dioxide and water is given respectively 76.2 kilojoule, 394.8 and minus 241.6 kilojoule per mole respectively. Calculate the amount of heat evolved by burning of 1 meter cube of methane measured under normal condition. This is given here 1 meter cube. So you have to find out for 1 meter cube. So to find 1 meter cube, first we have to find out per mole how much methane is giving heat. So if you see here, carbon is reacting with the hydrogen, so they will give you here CH4. Okay, so here if you solve it, so heat of formation of delta H is how much? Minus 76.2 kilojoule. Second, when carbon react with the oxygen, so they will give you here carbon dioxide. So in this case enthalpy is how much? Minus 394.8 kilojoule. Second, when hydrogen react with the oxygen, so they will give you here water as a gas, all are gas. So here delta H will be given minus 241.6 kilojoules. So we have three equations, 1, 2 and here 3 equations. So if you for finding CH4 plus oxygen, okay, so CH4 plus you have to fully CH plus oxygen, so you have to you will get value CO2 plus water. Okay, so this is our basically result. So this will be answer here 2. Okay, so to get this result, so what we have to do, so again so we multiply this above equation in such a way that is multiply 2 into third equation. Okay, and then if you minus, you add it a second equation and again subtract it first equation from here. Okay, so you will get the result. This here will get here CH4 plus 2O2. This result will get. So here you can do by inspection. We have to do this one. So 2 into 3 you have to multiply this equation into 3 whole. So you multiply 3 means this will double. So on solving this, you will get here value delta H is equal to how much? Minus 801.8 kilojoule. So in this way we solve it. Now this is the heat of energy per mole of when methane burns with the oxygen. So this is the per mole when methane burns it. So now so we can see from the equations. So 22.4 liter of methane. Okay, so burning, we can write here burning, it will giving you how much energy. So energy we have written here, so that is 801.8 kilojoule. So this energy given out. Okay, so this liter we can write in the meter cube form. So 22.4 liter into 10 to the power minus 3 meter cube we can write here, same thing. So it will giving your 801.8 kilojoule. So instead of meter cube, if you write it 1 meter cube, so it will give how much? So it will give you here 801.8 multiplied by 1 and divided by 22.4 into 10 power minus 3. So here after solving we will get here 35.795 into 10 to the power 3 kilojoule. So this much energy is given out by the methane when it burns in presence of oxygen.